Hello, my name is Pini Dibask, and I'm a product manager for database monitoring solutions with Quest. Welcome to the episode number 3 in this webcast series. This is the last episode, which will cover how Foglight Performance Investigator can help you solve database blocking logs mysteries. We will start this session with a quick recap of Foglight Performance Investigator, and then we will talk about some of the basic concepts of database management systems locking mechanism, which is an important mechanism to ensure database consistency and integrity for multi-user applications. We will then discuss about how to solve some of the blocking logs mysteries using Foglight Performance Investigator. So let's start with a quick overview of Foglight for databases. Foglight for databases is a heterogeneous solution for monitoring your entire environment across various database flavors from a single view. This solution supports SQL Server, Oracle, DB2, SAP ASC, MySQL, Postgres, MongoDB, and Cassandra. It's a 24 by 7 enterprise monitoring solution which allows you to effectively monitor your database environments. It features deep resource monitoring capabilities with powerful analysis toolset to quickly identify issues and proactively fix them before they become a real problem. This solution also offers comprehensive set of in-context and enterprise reports. It uses a remote agentless architecture which can basically monitor your environment remotely without installing anything locally on the monitored host or in the monitored database. So no schema objects are required in order to use the product. This solution can monitor the database from anywhere to anywhere. So we support customers who use both on-premise deployments, cloud deployments, and hybrid deployments. Here we can see the rich monitoring coverage that we have for Oracle, including various high availability and disaster recovery solutions, such as real application clusters, DataGuard, Arman, and OS clusters, nodes. Foglight has a very rich monitoring coverage for Oracle, SQL Server, and all the other database flavors. For example, here we can see in Oracle all the different aspects of high availability and disaster recovery solutions which are being monitored, such as DataGuard, real application clusters, Arman, etc. We also cover different storage aspects, including the automatic storage management, fast recovery area, redo logs, table spaces and data files, and of course objects. We support the 12c multi-tenant architecture and Exadata, so we're basically up to date with the recent technologies from both current and historical standpoints. Same goes for SQL Server. So if we see the extensive coverage that we have for SQL Server here, let's see, for example, here we can see some of the main features that we cover in Foglight for SQL Server. So for example, we monitor in-memory OLTP, always on, log shipping, tempdb, and basically you can name any feature in SQL Server and we support it. We also have a complete coverage of the BI suite. So we support SQL Server reporting services, integration services, and analysis services. Let's talk for a second about SQL PI. SQL PI stands for SQL Performance Investigator. It's analysis toolset for deep visibility into database performance. It's part of Foglight for Oracle and SQL Server, meaning that it has a web-based interface with a simplified deployment. You don't need to install anything locally on the monitored hosts or the monitored databases. And SQL PI supports all database editions and configurations. So for example, whether you're running databases on-premise or in the cloud, whether you're using enterprise edition or standard editions, everything is basically supported by the product. Let's talk about SQL PI analysis toolset. The first feature that I would like to mention is dimensional workload analysis. It allows you to break the database activity into various dimensions, such as SQL statements, programs, users, machines, objects, files, disks, databases, etc. So for example, it allows you to visualize the activity of a specific dimension, for example, a specific user or a specific program, at any point in time. It can also show you the activity for a combination of dimensions. For example, user sales that is connected to database HR and running a specific SQL statement 3 weeks ago or 5 months ago, basically at any point in time. So it's a very powerful tool to investigate the database workload activity and understand what is happening just by see visualization of the workload. Change tracking is also a very powerful tool because it allows you to correlate the database workload to the actual changes. It shows you a visualization and indications any point in time that we find a change in the database. It could be either object change, for example, index was dropped, table was modified, execution plan change. So every time we find a new execution plan for a specific SQL statement or batch, we show that on top of the workload chart. Configuration changes. So for example, every time we find any parameter which has been changed, or maybe a file configuration change, maybe a new data file was added to the database, we basically collect that as well. So it allows you to see a correlation between changes in database workload. For example, you can see that exactly at the same point in time where index was dropped, there was an increase in the I/O activity. So it allows you to understand what caused the increasing activity of the I/O. Compare tool is also powerful. It allows you to compare between instances and dimensions. So for example, I can compare between my production database to my testing database. I can also compare between one SQL statement to another, between users, between programs, machines, etc. It can also show you a comparison of various configuration parameters. So if you would like to ensure that your production and test environments are running with the same parameters, you can do that using Foglight Compare tool. The I/O analysis feature allows you to investigate I/O related activity for every dimension, including objects, files, and disks, so you can see the associated I/O statistics such as physical writes, block changes, physical reads, logical reads, etc., and also the associated I/O wait events. For example, it can show you also all the SQL statements that accessed a specific file, disks, object, which is very powerful if you would like to understand what are the hot objects in your environment. The log analysis is very powerful if you would like to investigate log activity. As we all know, performance issues which are a result of blocking logs could be common. It's very important for the application designers, the application developers to make sure that the code is written in a way that there are no concurrent access to the same shared resources, such as tables, indexes, partitions, because if that may happen, the database can wait due to blocking logs. So this tool allows you to see the log trees of all the dimensions at any point in time. For example, you can see under a specific database who logged who, when, what was the duration of the log, what was the SQL statement that was waiting for the log, etc. Execution plan analysis. It allows you to analyze execution plan by viewing all the historical execution plans, see various statistics about those execution plans, and even compare between different execution plans. Before we discuss about how Foglight can help addressing some of the blocking logs mysteries, let's briefly review the database locking mechanism concepts. The purpose of locks in database systems is to maintain database concurrency and consistency when multiple transactions access the same shared resources. The reason I say shared resources and not just tables or rows is because there are various types of shared resources in a database. It could be rows in a table, entire table, index, stored procedure, etc. The need for locking mechanism is a result of having multiple user sessions which may access same shared resources, and by doing so, they can cause logical corruptions to the data. In fact, if in our database world we always had one single session, one single transaction in the database that is running and updating data or altering data structures, locks were not really required. Database locks affect the interaction of sessions that read and write data, and in some cases, if the application is written poorly, there might be a significant performance degradation due to lock weights of sessions. It's also important to mention that each database management system has its own locking mechanism. The way Oracle database locking mechanism is implemented and works is different than the way it works and implemented in SQL Server. For example, Oracle database never escalates locks from one level to another. When modifying data, Oracle will always use only row-level locking, whereas in SQL Server, lock escalations may occur in some scenarios. This is just one example, but there are many others. Even though every database management system has its own implementation and nuances for the locking mechanism, the one common thing is that blocking locks could cause some performance degradation, and we as DBAs and application developers need to address those scenarios. We've covered the basic concepts of database locking mechanism, and now I would like to show you how to use Foglight Performance Investigator to isolate the root cause of database lock weights. Here we can see Foglight Performance Investigator dashboard. This is the screen that shows all the useful information about the database workload activity. The first thing that we can notice is the workload chart. We can see a breakdown of three resources that are being used. The green color represents CPU activity, the red color represents application weights, application locks, and the blue color represents I/O activity. The pie chart in the right section of the screen shows a breakdown by percentage. So we can see that application weights, application locks consumed 70% of the total instance activity. Let's take a look at the left section of the screen where we can find the Foglight Performance Investigator performance tree that shows all the dimensions of the product, such as programs, SQL statements, database users, machines, files, disks, objects, etc. Now I would like to talk about the locked objects dimension. So let's zoom and see the locked objects dimensions. So we have here three objects under the sales schema. We can also find them at the table below, and for each one of them we can see the associated wait time. If you would like to further drill down and see which statement accessed the locked object and which statement actually waited due to a blocking lock, we can do that by drilling down into the performance tree. Let's see how we can do that. So in this case, I looked all which programs access the sales.employee table, and we can see here that we have program Toad. We can further drill down and see which SQL statements under program Toad access the sales.employee table. And now we can see the SQL statement. If we would like to see historical lock trees to understand who locked who, when, why, what was the duration of the lock, what SQL statement was waiting due to a lock, which machine the session of the blocker session and the blocked sessions are connected to, we can do that by clicking on the blocking history tab. So let's explore the blocking history tab. We can see here that we have 4 lock trees. For each one of them, we can see when the lock event started. We can see the session identifier. It is represented by the SID and serial number in Oracle. In SQL Server, we will see the session and the logon time. We can also see the status of each one of the sessions, whether it's a blocker session or blocked session. We can see the duration of the lock. We can see which program the session was connected from. We can see the database user of the session. We can see the SQL state that is waiting. So in the case of the blocked session, we can see which SQL statement is actually currently waiting. We can also see the database that the session is connected to. So in this case, we have 4 lock trees. And what is really nice about this is that I can filter the lock trees to any point in time in the history. In Foglight Performance Investigator, we store all the lock information in our embedded repository. So you can see all the log trees from 5 months ago, 1 year ago, 2 weeks ago, whatever time is right for you. So it's very, very useful. Another useful capability is to filter the information of the log trees by specific dimension. Perhaps I would like to investigate log trees only for a specific database or only the log trees that are associated to a specific database user. I can do that just by clicking on the performance tree at the left section and choosing the right dimension. In this case, I chose to filter all the information for the OLTP database. So I can see that I have two log trees. One is associated to the sales.product object. That's the first object that is being locked. And the other one is the sales.employee object. And I can see the status. We can see the status of each one of the sessions, whether it's the blocker session, the blocked session. I can see that in both cases, the sessions were connected to Toad. I can also see the SQL statement that is waiting. So in the first one, it's an update command, and also in the second one. This really allows us all the flexibility we need in terms of drilling down into a specific dimension and filtering the information by a specific time range. If you would like to learn more about the product, feel free to visit our website, Forget for Databases. We also offer a free web-based course, which is available on ToadWorld, our database community website. Okay, so I hope you enjoyed and thank you for listening.